welcome back. In this video, we're going to explore another method for finding the greatest common factor, the slide method. This is a very practical method, especially for larger numbers. Let's start with 900 and 360. For the slide method, we write these numbers next to each other at the top. We can see that these numbers do have a 10 in common. So we write a 10 over here and we divide. 900 divided by 10 is 90, and 360 divided by 10 is 36. So now we have 90 and 36. These have a 2 in common. 90 divided by 2 is 45. 36 divided by 2 is 18. 45 and 18 have a 3 in common. 45 divided by 3 leaves us 15, and 18 divided by 3 leaves us 6. These also have a 3 in common. 15 divided by 3 is 5, and 6 divided by 3 is 2. They have nothing in common. So to find our GCF, we actually multiply the first column. So our GCF here will be 10 times 2 times 3 times 3, which is 180. So the GCF of 900 and 360 is 180. Let's do this again for the numbers 1080 and 1200. Both of these do have a 10 in common. When I divide by 10, I'm left with 108 and 120. These numbers have a 2 in common. That leaves me with 54 and 60. These once again have a 2 in common, and I'm left with 27 and 30. It is important to note that we may have recognized that 108 and 120 have a 4 in common and did 4 instead of 2 twice, and that's fine. How we break it up is not important. 27 and 30 have a 3 in common, and that leaves me with 9 and 10. These have nothing in common. So our GCF comes from that very first column. 10 times 2 times 2 times 3, which is 120. So the GCF for 1080 and 1200 is 120. Let's do this one more time. For 675 and 1125. Both of these have a 5 in common. 675 divided by 5 is 135, and 1125 divided by 5 is 225. These also have a 5 in common. 135 divided by 5 leaves me with 27, and 225 divided by 5 is 45. These have a 9 in common. 27 divided by 9 is 3, and 45 divided by 9 is 5. 3 and 5 have nothing in common. So my GCF comes from that first column. 5 times 5 times 9, which is 225. So this is the GCF of 675 and 1125. Now, let's connect this to powers in the greatest common factor. Let's consider two numbers. 2 to the 6th times 3 to the 4th times 7 cubed, and 2 to the 5th times 3 to the 10th times 7 to the 5th. To find the GCF, we want what they share. That means for each prime, we use the lowest exponent. So for 2, we use 2 to the 5th. Since out of 6 and 5, 5 is smaller. For 3, we use 3 to the 4th, since 4 and 10 has 4 being the smallest. For 7, we use 7 cubed, since 3 is smaller than 5. So our GCF is 2 to the 5th times 3 to the 4th times 7 cubed. Let's repeat this for 2 to the 7th times 3 to the 8th times 5 cubed, and 2 to the 9th times 3 to the 4th times 7. So let's compare the primes. For 2, we use the lower of the two exponents, 7. For 3, the lower of the two exponents is 4. The first expression has a 5 cubed, but the second has no 5. The second expression has a 7, but the first has no 7. So only the primes they share count. That means our GCF is 2 to the 7th times 3 to the 4th. This is such an elegant shortcut. For GCF, we keep only the shared primes and use the smallest exponents. That fits perfectly with the meaning of greatest common factor. We want the biggest factor both numbers can still share. In the next video, we'll find the LCM using prime factors and Venn diagrams.